Hey everyone, and welcome. Today we're going to break down a concept that's, well, absolutely fundamental to algebra: absolute value. It might sound a little intimidating at first, but I promise, by the end of this, you'll see it's really just about one super simple idea. Okay, let's get into it. To get our brains warmed up, let me ask you a quick question. Picture this. You get in your car and drive 5 miles north. At the exact same time, from the exact same spot, your friend drives 5 miles south. So who's farther away from your starting point?
It's a bit of a trick question, right? The answer is neither of you. You've both traveled the exact same distance, 5 miles. When we're just talking about how far you went, the direction, north, south, east, west, it just doesn't matter. And that idea right there is the heart of absolute value.
So let's take that core idea. It's all about distance, not direction, and see what it looks like in the world of math. We're moving from a driving analogy to the actual definition. Okay, here it is, the official definition. Absolute value is simply a number's distance from zero on the number line. That's it. It's not worried about positive or negative. It only asks one question: how far? And in math, of course, we have a symbol for this. It's these two vertical bars. When you see a number tucked inside these bars, it's just a signal, a command, to find that number's distance from zero. You know, an easy way to think about it is like, these bars are a little positivity machine. Any number you drop in, whether it's positive or negative, comes out positive. Why? Because think about it, you can't travel a negative distance, right? So let's try it out. The absolute value of -5 is +5. Why? Well, if you're standing at -5 on the number line, how many steps does it take to get back to 0? 5 steps. That's the distance. And what about a positive number? Even easier. The absolute value of 5 is just 5. It's already positive, and it's already 5 steps away from 0. Simple as that. And of course, we can't forget about 0. The absolute value of 0 is, well, it's just 0. It hasn't gone anywhere, so its distance from itself is 0. Okay, if you remember only one thing from this whole explainer, make it this. This is the golden rule. Distance is never negative. That means the result of an absolute value calculation is always going to be positive, or 0. It can't be negative, ever. All right, the theory's great, but let's put this into practice. It's time to solve some actual problems and see how these rules work step by step. Let's start with a nice, straightforward one. We've got the absolute value of -7 plus the absolute value of 3. So first things first, you handle each set of bars on its own. The absolute value of -7 becomes 7. The absolute value of 3 is just 3. Now it's simple addition. 7 plus 3 is 10. Done! Ooh, okay, now this one's a little tricky. See that negative sign just hanging out on the outside of the bars? This is super important. You have to treat the absolute value bars just like parentheses. So you solve what's inside them first. The absolute value of -6 is 6. Then that negative sign that's been waiting patiently outside gets applied, making our final answer -6. All right, here's another big rule. If you have math happening inside the bars, you have to do that first. So we solve 2 minus 9, which is -7. Now we have absolute value of -7. And what's the absolute value of -7? It's +7. Okay, so we know the rules, but it's just as important to know the common traps people fall into. Let's look at a couple of the biggest mistakes that students often make with this stuff. This is probably the #1 mistake I see. People try to distribute a negative sign into the bars, but you just can't do that. Look, if we do it the right way, we solve inside first. 5 minus 2 is 3. Then we apply the negative to get -3. But if you try to distribute that negative, you get a totally different and totally wrong answer of +3. And here's the second big trap. If you ever see an equation that says an absolute value equals a negative number, you can stop right there. It's a trick question. Just remember our golden rule. Absolute value is distance, and distance can't be negative. So a problem like this has no solution. So at this point, you might be thinking, okay, this is cool, but when am I ever actually going to use this? Well, it turns out you see it in the real world all the time. Let me show you a perfect example. Think about manufacturing, making anything from a car part to your phone. Let's say a machine needs to cut a part that's exactly 10 inches long. Now, in quality control, they don't really care if the part is 0.1 inches too long or 0.1 inches too short. Either way, it's off by the same amount. All they care about is the size of the error, and that's exactly what absolute value measures.
And this isn't just a textbook example. This is the kind of formula engineers and quality control teams use every day. They take the absolute value of the actual length minus the target length, and that number has to be less than or equal to the allowed error. It's a super clean, efficient way to make sure everything fits perfectly.
Okay, so let's wrap this all up with a little food for thought. We've totally nailed the idea that absolute value is about distance on a one-dimensional number line, right? So how do you think we could use that same core idea to measure the straight line distance between 2 points on, say, a two-dimensional map? Ponder that for a bit, because you're already thinking one step ahead. Thanks for watching.